Well, good morning. It's 11:37. Just turned 38 on Thursday, the 21st of March, 2019. It's supposed to be linear algebra class, and it seems like almost as normal. I'm the only one in the room right now. Hopefully some more will be coming in. Let me go from current slide if it'll go there. There it goes. So we are... See, last time finished chapter 2, and I think I did give you a test, if I hadn't given it already, for chapter 2. We're starting chapter 3 today. Well, we started it last time, but just barely got going in it. We'll be continuing 3.1 today. Now, 3 is a much shorter chapter, and I think it's going to be easier to finish quickly. So we'll move right along, which leads me to suggest strongly, let me say too, let me do couple of things first. I forgot to mark the rest of the roll in the previous class. Okay. So let me say this about this class. I have received just one research paper, okay? We only have, once we get back from spring break, 1 month left. And that's all, folks. 1 month left. So I'll need some more papers coming in, and spring break is a great time to work on them. Okay, test 1, 3 people have turned this in so far, and that means there's 1, 2, 3, 4 of you have not. So I need those in because the test 2s are out there and I don't have any of those in, and because I just gave it to you recently. But then chapter 3 test is going to be coming up pretty quickly. So please take advantage of your spring break, use it wisely, and see if you can get caught up, because some of you still don't have any grade to put down for you. And I'm afraid I'll find out tomorrow that we're supposed to do midterm progress report, or have already done them. So I'll probably need to be putting some things down there for those. All right, so let's pick up on in chapter 3, 3.1. The determinant of a square matrix. Now this is where we were going to begin last time, and this is really a tedious operation because they're dealing with letters, not with numbers, and it's real easy to get the subscripts screwed up because there's so many of them. Okay, so here's your system of equation. Let me get my pen set up. Okay, A11 x1 plus A12 x2 is equal to B1. A21 x1 plus A22 x2 is equal to B2. All right. Simple enough looking things, only too many subscripts. Okay? All right. Now, if you were going to solve this by elimination by addition, is what that used to be called, what we would do is typically multiply let's say solve for x1, we would multiply the top equation by an A21 let's make that a minus A21 and multiply the bottom equation by a positive A11. So I think, yeah, that should do it. Okay? All right. Now this, I admit, is going to get messy looking, but it'll work. Hang on. So multiplying the top equation by minus A21, you get A11, minus A11, A21, x1. Okay. Sorry, I just did it backwards. Okay, sorry about that. We're solving for x1. That's what I was planning to do. let me erase, start over again. Okay. May have been okay, but I just realized I was eliminating the x1. We want to solve for x1, so that means we're eliminating x2. So let's multiply the top equation by an A22, bottom equation by an A12, but we need to make one of those negative, and I believe the A12 is the one we'll make negative. Okay? Now let's see what we got. We've got an A11, A22, x1 plus A12, A22, x2 is equal to A22, B1. All right. Second equation, minus A12, A21, x1 minus A12, A22, x2 equal minus A12, B2. Okay. Carried away with my A's there. Okay. What you see here is that you've eliminated your x2s. So that gives you A11, A22 minus A12, A21 times x1 is equal to A22, B1 minus A12, B2. Divide both sides of the equation by this parenthetical form here, and that will be A11, A22 minus A12, A21. Okay, and this side it would cancel. I didn't copy it down, but so there's what your x1 is. A22 B1 minus A12 B2 over A11 A22 minus A21 A12 A21. Okay. And I think, except for maybe the order of things, that's exactly what they've got. They write the B1 first, like I said, the order. B1 A22, which is our first term in the numerator, minus B2 A12, our first term in the second term in the numerator, divided by A11 A22, exactly what we had, minus, and then they wrote the A21 A12. They just reversed the order there. Okay. Now, what I was starting to do before, or close to it, is what we would do to eliminate the x1 and solve for x2. So I'm going to we want to eliminate x1 and solve for x2. So this time, I think it's like I was going to do before. There. I think that's right. This time we'll multiply the top one by A21, the bottom one by A11, and we'll negate the top one this time. I believe that will work for us. Okay? And if you do that, you get minus A11, A21 times x1 minus A12, A21, x2 equal, and I'm going to erase this other for now if that's okay, because that divided out anyway. So that gave us our x1 there. That looks a little neater anyway and gives me room to write here. and this will be a minus, and they usually write the B's first, so I'll write the B first. B1, A21. I don't know why, but they do. Okay, or later I think we'll see why. Okay, second equation is a A11, A21, X1, plus A12, A22, X2 equal, they do write the B first, I don't know why, B2, A11. Okay. Now, this time you see the first terms are eliminated. You add them, they go to 0. So that gives you an A12, A22, I'm going to leave off the X for now, factor it out. Okay. That's the numerator one because that's positive, minus A12, A21. Both of those are multiplied by X2, and that's equal to B2, A11 minus B1, A21. All right. And again, divide by this coefficient here, the parenthetical thing there. I'm not going to write it down, but I will write it here. A12, A22 minus A12, A21. Okay. These will cancel out because they're the same thing. And this gives you what they got for X2. B2, A11 minus B1, A21 divided by, and they wrote it, whoa, I don't know what I was doing, but I wasn't paying attention. I think it's what it was. For our second equation here is A11, A21, X1 plus A, that should be a 1, 1. Okay. A11, A22, X2 equal B. Yeah, I just wrote the wrong number in there. So therefore, that should be a 1 there and a 1 there too. Okay, A11. No, I erased the wrong one. Sorry, let me go back and change. All right, I'm totally confused now. So X2 will be, okay, this term here would have been all right, A11, A22 minus A12, A21. So that's A12. No, this is the one I should have changed. Okay. I think that's right now. Divided by A11, A22 minus A12, A21. Got it. Okay. And the numerator is, I think, correct the way we had it. Okay. And let's see if that we got it right now. X2 is equal to, this X2 is equal to B2 A11 minus B1 A21 over A11A22 minus they wrote it in the reverse order, A1, they wrote 21A12, we just rearranged the order. Multiplication is commutative, it doesn't matter. So those are our two solutions, generally generic solutions. Any coefficients you plug in, they come out here. They're just a lot easier to keep track of when you don't have all the subscripts. Now, the thing to notice here, sorry, I've got the hiccups. These denominators are exactly the same thing. A11, A22 minus A12, A21, or A21, A12. It doesn't matter which order you write them. Okay? They're exactly the same. What's more is that that is your determinant of your coefficients of the variables. A11, A22 minus A12, A21. That's exactly that determinant. Okay? Remember when we did that earlier, that's how we defined the determinant. Now, what are the numerators here? Okay? Well, if you had, when you solve for x1, okay, then your if you'll notice this determinant here, the bottom that way minus the top this way. So it's, if you had subtracted the x2s from both sides, that would have been exactly, well, no, that would still wouldn't have been quite it. But it is something similar to that, not exactly the same. And for the x2, it would be almost the same thing. It would have to do with the x1 coefficients determinant with the x2, but we'll get to that. Okay, so it looks like you can solve systems of equations just using determinants. That's what it's getting up to. As long as that product here, that determinant there, is not equal to 0, and guess what? If the determinant's not equal to 0, you have a solution. I think we did that before. So, at least for a 2x2. And if it's not, then you can come up with a solution. So the determinant of a matrix A, okay, where A is your coefficient matrix, A11, A12, A21, A22, if that's your matrix, the determinant of that matrix, which I like to use this symbol, determinant of A, okay, it's a lot easier writing DET. The book likes DET. I just like the bars, determinant of A. Doesn't mean absolute value of A, because A is a matrix, not a number. So that's the determinant of the matrix, because the determinant could be positive or negative. And that would be the down diagonal, A11, A22, minus the up diagonal, A21, A12. And that's why they wrote them in that order, because that's how we usually do it, the up diagonal. Up diagonals are negative, down diagonals are positive. Okay, that's the determinant of any old matrix A. It doesn't have to be a coefficient matrix. It just happens to work that way if it is one. Okay, so let's do example 1. Clear the ink and do it. Here's matrix A. Oh, goodness, be still my heart. Okay.
I normally have that fit.
Huh?
I normally have that fit.
Yeah. Showing up? Oh.
Hello, man.
No. I don't know why Justin's not coming to class. He came by my office right before class. I thought he was going to be here, and he picked up his second test in differential equations. I asked him which class, and he said you had told him, so I figured it must have been that one. But now I'm wondering, did he pick up the second test in this one? Or do you know?
Well, I told him you had given out both tests.
Okay, well, he said for the class. I said, which class? Because yeah. So
he should be taking both classes.
he is taking both, and that's why I asked him which class. And he said differential equations. Well, he first said algebra, and I thought he meant pre-calculus algebra. I thought you're not even in that class. He said, no, differential equations. I said, oh, okay. Because he said you had gotten it for him. You had told him yesterday, and yesterday I gave you the differential equation test.
Right.
But were you here Tuesday?
I was not here Tuesday.
Oh, so you probably don't have the second test from this either.
Right.
Okay. Okay, get it before you leave today.
Yeah, you gave me one test yesterday when I turned it in. I think that was for
That was differential equations, I thought.
I think that is for differential.
Right. So did you get the test for linear algebra?
No, not
second test. Okay. Well, then you turned in the first test for linear algebra.
First test for differential equations.
Yeah, right. Okay. Okay. So before you leave today, will you see Justin?
I don't see him. I just normally talk to him through the phone. He said he doesn't really have his car anymore.
He what?
He said he doesn't really have his car.
Oh.
He said I don't know. I think he's taking somebody else out in the house, so it's hard for him to get back and forth to school.
All right. Well, that's the thing. He was just in my office at the break between classes. I thought he was going to be here, and then he wasn't. And I thought, well, he probably needed this test too. So, but you won't see him, you don't think?
I don't know. I'm gonna see him.
Okay. Let me turn on the projector and turn on one light. Okay. So like I said, in the last class we finished chapter 2, and I gave you the test for chapter 2, but you weren't here, but I passed it out to those who were. And yeah, there were just 2 people here. So, this is in chapter 3, 3.1, on page 104, example 1, bottom of the page. Now, just have talked about what a determinant is, and we're going to do one. Okay? 2 minus 3, this is a matrix, 2 minus 3, 1, 2. Now, we've done determinants before when we were doing stuff earlier. This is just sort of reinforcing them. Now, that is A. What is the determinant of A? And the vertical bars on either side of a matrix doesn't mean absolute value. Their matrices don't have absolute value. They mean determinant of that matrix. Okay. Now, because determinants could be positive or negative, so don't get it confused with absolute value. Absolute value is always positive. A determinant is a number. Okay. So how we write this is this way: determinant of 2 minus 3, 1, 2. And that determinant is, and here's how you calculate. I don't know if you remember it. Down diagonal, you multiply those, and that's always positive. So that would be a 4. The up diagonal is always negative. Multiply those two together. 1 times negative 3 is negative 3, but then you negate it, so that would be plus 3. So that determinant is 7. Okay? Now, a lot of times with determinants, a lot depends on whether they're 0 or not 0. Really doesn't matter much else. Well, it matters some, but the main thing is whether it's 0 or not. This one's not 0, so that means that matrix is an invertible matrix. If the determinant of a matrix is 0, it's not invertible. If it's not 0, it is invertible. That's why I said that's a big key, whether it's 0 or not. that determinant is not 0. Okay? Now, here's B. 2142. What is the determinant of B? You do that one. 2142. What would be its determinant?
1. Oh, my God. So it'd be 4.
4.
And then
Where'd you get 3?
negate it, right? So it's subtracted.
You multiply them together,
Right.
but negate it. Do the,
So it'd be,
yeah,
negative 4.
minus 4. So guess what? That determinant is 0, meaning this is not an invertible matrix. Now, we technically haven't gotten there yet, I'm just telling you. With a 2 by 2, it's going to be real easy to tell, because one of these is a multiple of the other one, and sure enough, the second one is twice the top. Not only that, the columns work that way too. This one is twice that one. So either rows or columns, if you see a multiple like that, you know it's not going to be invertible, and it's not. Well, we're not worried about that yet. The determinant is 0. Okay? So let's do C. 0 2/3 2 4. What is the determinant of C? That would be the determinant of 0 2/3 2 4. 0. Okay. You don't just go and leave it in fractional form. Minus 4/3. 2 times 2 is 4 divided by 3. That's minus 4/3. And for right now, all you know, it has a non-zero determinant. Okay. Which later we'll say that means that's an invertible matrix. Okay. All right. I must have written something wrong. It's not 2/3, it was 3/2. I was going to say, that's not the answer we got. Okay. That's because I wrote the problem wrong. Okay. Let's see if I can write it right this time. 3/2. So, 0 on the down, and what's on the up? Minus 2 times 3/2 is 3. And that's equal to negative 3. All right. Sorry about that. All right. Now, 2 by 2s are a piece of cake. Real easy to do. That's it. Dip. 2 multiplications, 1 subtraction. Or addition if the number happens to be negative. Okay. Doing bigger ones, they enter into this. This to me is the most difficult part, and it's not hard, it's tedious. Part of matrices is dealing with these minors and cofactors, and then keeping up with what's what and how you do with it. The definitions are awkward, clumsy, but when you actually do it, it makes more sense. So let's hit the definitions first, clumsy as they are. Let's go. To define the determinant of a square matrix, and by the way, the only matrices that have determinants are square matrices. You can't do a determinant on a rectangular matrix. It has to be square. Okay. So, that said, goodness, my eyes are stinging like crazy. If you're doing anything higher than 2, like a 3 by 3, 4 by 4, 5 by 5, they have to be square. Then you need to get some more. You need a bigger vocabulary to talk about what you're dealing with. So, we're going to talk about 2 things. The first is called minors, That doesn't mean they're either underage or they dig down in the ground. That's neither one, but they're spelled like underage. And cofactors. Now that's a really big seeming word, and it's a really simple concept. So we'll get there. So if A is a square matrix, okay, then the minor okay, MIJ, I can't read my little print here, of the entry IJ. Remember, AIJ is in the ith row, the jth column of that matrix A. That's an element, okay? AIJ is one of those things in the matrix. Wherever it's located, that determines I, it determines J, okay? The ith row, jth column. The MIJ is not a single value like that. It turns out being one, but it's really not. It's a matrix itself. And that's one reason perhaps that they have a capital letter. Okay? So MIJ, the minor MIJ of the entry IJ is the determinant of the matrix. So actually it is just a number. Determinant of the matrix obtained by deleting the ith row and the jth column from A. Okay? Now, the minor MIJ of the AIJ, the element AIJ, is the determinant, okay, of the matrix A, they should say, they don't say the matrix, obtained by eliminating the ith row and the jth column of A. Okay? Now, the cofactor, now this is really complicated looking. Cij of the entry IJ, AIJ, okay, is, all right, Cij is equal to minus 1, the number minus 1, raised to the ith plus jth value, add I and j together, the subscripts together, and then multiply it by Mij that you just determined. Okay? You go, what? What in the world are they talking about? Why is this so complicated? It really isn't. This just makes it sound really bizarre. And it's strange enough, but it really isn't too bad. Okay? So, yeah, let me go on and do it here. Let's say we have a 3 by 3. Okay? A11, A12, A13, A21, A22, A23, A31, A32, A33. All right. To get the minor of this one, here's Daniel. Oh, goodness gracious, I'm tired. End of the week, I'm just running out of juice rapidly. Every day it seems like I lose more sleep. So by the end of the week, I'm just barely. And then to I'm a tad on the hungry side because it's been a long time since breakfast, but during the break, between classes, I crammed down a granola bar just to give me a little more energy, but here we go. All right. Now, you pick an A, any one of those 9 A's. Pick one.
A 2-1.
2-1?
2-1.
Okay. This one right here, right? Okay. So to get the minor of this matrix A, this is matrix A. To get the minor of A, we'll eliminate that row and eliminate that column. Not completely, but just do that. The minor of 2-1 is in the matrix that's left over, the determinant of the matrix that's left over, which is A12, A13, A32, A33. The determinant of that. That's what the minor is. Eliminate the row, column, and write down the matrix that's left. Take the determinant of the matrix that's left. What is the determinant of this one? A12, A33, minus A32, A13. It doesn't matter what order you multiply them, but just get them right. Okay? That's the minor. Okay? Now, to do the cofactor, okay, it's just one more step. It's either the same as the minor or it's the opposite of the minor. Now, what it says to do here is take the number minus 1 and add the I and j together. Since you chose 2, 1, right? 2 and 1 is 3. Minus 1 to the third power is?
You said minus 1 to the third, -1?
Negative 1. Minus 1 to an odd power is negative, to an even power is odd. Okay? I mean, to an even power is positive. Okay? This just happens to be. So, what a pain in the neck to take -1 and raise it to a power. You want to know the easy way to do it? The upper left is always positive. And start from here and either go right or left or up or down. It doesn't matter. But just do a step like that. Plus, minus, plus, minus, plus, minus. Plus, minus, plus. Plus, minus, see, it's still minus, plus, minus, plus, plus. However you do it, these are going to be pluses, these are going to be minuses, these happen to be pluses again. Okay? Whatever size you have, you can always do it that way. That, to me, is so much easier than adding I plus j and then seeing whether it's plus or minus. So the cofactor C21 is equal to minus the minor, which is A12, A33 minus A32, A13. It's just either putting a minus in front of it or not. Okay? So the cofactor is either the same as the minor or it's the opposite of the minor, depending on where you are. Okay. Okay. So let's do example 2. Find all the minors and all the cofactors of this A. Oh my goodness, wait a minute. Whew, goodness. Too much to take in at once. Okay. Muhammad is here. Okay. Yeah. Okay. Here is matrix A. We're at example 2 on page 105 in section 3.1 of chapter 3. And by the way, I can't remember who was here and who wasn't before, but before you leave today, be sure you have a copy of the second test. Okay? Did you get one last time? You did. You did, but you didn't. Okay. All right. And if you see or hear from Justin, if he wants to catch me later today, I'll be here till 6 tonight. I'll be in class most of the time, but I'll be on campus till 6. And I'll be on the Birmingham West Campus, Dr. Pruitt's office, from 8 to 12 tomorrow. But if he needs a test, he needs to let me know to take one over there. Okay. All right. So here's, I feel bad I didn't give it to him because, so what class are you talking about? Because I knew he was in 2 classes. I thought he'd be coming to this one because he was right there in my office, so I didn't bother about this one. Okay. 0, 2, 1, 3, -1, 2, and 4, 0, 1. Okay, there's matrix A. I hope I copied it right. Okay. It says find all the minors and all the cofactors of that. Okay? Now, where do you want to start? 1, 1? Upper left? Okay. So let's start with this one. So we're going to do M, 1, 1. Okay? So how do you get the minor? Eliminate that row, eliminate the column. Okay? So the minor is going to be the determinant of what's left, -1, 2, 0, 1. And what's that determinant? -1. That's it. Okay? Now, what's the cofactor? It's either that value or the opposite value. How do you know which it is? Determine the sign. Plus. Okay, that always is plus. This one's plus. Or you can add these two together as even. That's going to be plus. Either one of those. It's -1 raised to the some power. So that's plus, so the cofactor is also -1. It doesn't change the sign. If the minor was -1, it's -1. If those added to be an odd number, then it would change the sign of the minor. This one keeps the sign the same. Okay, which one you want to do next?
3.
You mean the number 3?
Yeah.
Okay, got it. Okay. All right. I thought you were going to say 3, 1 or 3, 2. Okay. Got it. We're going to do this one. All right. So what entry is that? It's the 2, 1 entry. Okay. So now we're talking about the minor of 2, 1. Okay. So we eliminate the row and eliminate the column. And what do you get as the minor? Second? Okay, the determinant of 2, 1, 0, 1. And what's the determinant of that? Second? 2. Perfect. What's the cofactor of that? No, -2. Because the sum of these subscripts is odd. Or, the other way to look at it, this one's always plus. It always starts with a plus, upper left. Plus, minus, plus, minus, plus, minus, plus, minus, plus. That turns out being minus. Or going down. Plus, minus, plus, minus, plus, minus, plus, minus, plus. They always start out the same. So that's a minus. So it's the opposite of the minor. The minor was 2, the cofactor is -2. Okay. Which one you want to do next? 3, 1, 4? This, yeah, okay. So I'm going to leave that one in. Okay. So this time we're doing 4, which is 3, 1. So you eliminate the third row, first column. 3, 1. Okay. So the minor for 3, 1 is? Huh? Yeah. Do you want me to write it again, or can you just do it up here? 4 plus 1, minus a minus. The up is always minus, and that's a number minus. So 4 minus 1 is, 4 plus 1 is 5. Okay? What is the cofactor? 3, 1. Second?
Would it be a plus?
Yes. It's also 5. It doesn't change the sign because plus minus plus. Right. Exactly. Okay, which one you want to do next? See, these aren't hard to do at all. You know. What you want to do next? 1, 2. Okay. Perfect. Let me get my pen. So 1, 2 will be this one, right? Okay. And so we'll eliminate the first row, second column. Okay. So what is M 1, 2? Okay. It would be 3 minus 8 is what? Minus 5. Right? Everybody see that? Okay. And what's the cofactor? 1, 2. No, it's positive 5. Because this is odd, change the sign. Okay. Wow, good crowd. Vince is here. Okay. Now, say this again. The last class, I passed out the test for Chapter 2. So if you didn't get it, be sure you get that before you leave. Okay. We're now doing minors and cofactors of matrices. This is all under the concept of a determinant. Okay? And have you done determinants? Do you remember that?
I've done them before, yeah.
Okay.
It's been a minute.
So, yeah, let's do. Which one do you want to do next? We just did 1, 1, 2, 1, 3, 1. We did 1, 2. What you want to do next? 2, 2? Okay. We'll do 2, 2. 2, 2 is negative 1 there, right? So the minor for 2, 2 is we'd eliminate the column. I already did that, and the row. So those are done. So what do you have? Right. I heard the 0 part. Second?
4.
Yeah, just the number 4?
Yes.
It's minus 4. Because the up diagonal is always negative. The down diagonal is positive. 0 times 1 is 0. Minus the up diagonal, 4 times 1 is 4. So minus 4. You see that? Okay, so that's a minus 4. How about the cofactor for 2, 2? Okay. No. It's what?
4.
Okay. It's also minus 4. Why? No. Why? If this number is even, the sum of these is even, it stays the same. If the sum is odd, it changes. Okay? Or, plus, minus, okay. You do that. Plus, minus, plus, minus, plus, plus, minus, plus. However you get there, that's going to wind up a plus. So it's the positive of that value. If that's a negative, it stays a negative. The minus here changes the sign of that. The positive keeps it the same. Okay? You see? Okay. Now, which one we don't want to do next? 3, 2? Okay. All right. So, we're going to do minor 3, 2. There's the, we'll eliminate the third row. That's of 0, by the way. Eliminate the third row, second column. Okay? Can anyone tell me the minor right now? Negative 3? Is that what you said? Perfect. Because 0 is down the diagonal, your determinant is 0. I mean, is positive. Up is negative. So that would be a positive 0, because 0 times 2 is 0, minus 3 times 1, which is minus 3. So what would be the cofactor 3, 2? Is what? Positive 3. Why? Because that's an odd number, you change the sign. Or plus, minus, plus, minus. Plus, minus, plus, minus. It's a minus. That's the minus entry, so you change the sign of whatever the minus was. Okay? Which one you want to do next? One, 3? Okay. Okay. 1, 3. That's going to be that one. Okay. So M of 1, 3 is going to be what? Eliminate that row, that column. That column. Okay. And then do the determinant. 4. Perfect. Because it's positive 0, which is just 0, minus a minus 4, which is positive 4. And then the cofactor for 1, 3 is going to be what? It's what?
Will stay the same.
Stay the same. 4. Perfect. Okay. What you want to do next? 2, 3?
Yes.
Yeah. Okay.
So,
Yes.
when you're doing the plus minus plus, as long as you start with the plus at the very top corner, the little corner,
Yeah.
it'll always, with whatever way direction you're going, it'll always equal out to the same, right?
Yeah. They're always going to be the same, right? Yeah. Okay. Now, 4x4, the pattern will be a little different, but you still do them the same way. Yeah. Okay. So, M of 2, 3, right? Is that what we're doing next? Okay. So, eliminate the second row, third column. Got it. What's your minor? Second? Negative 8. What's the cofactor? 8. Perfect, because that's an odd sum of your suffixes, or whatever you call those, subscripts, and since it's an odd sum, then it's to change the sign. And the last one is M of 3, 3. Okay? So let me, ooh, it didn't pick up. Okay. So eliminate third row and third column. We're doing that one. And what do we have? Negative 6. And what's the cofactor of 3, 3? Minus 6 as well, because that's an even sum, meaning you keep the sign the same. Okay. Let's see how we did, or how they did, or how somebody did. M11 was minus 1, as was C11. M21 was 2, oh yeah, we went that way. 21 was 2, and the C21 was minus 2. M31 was 5, and the cofactor was also 5. M12 was minus 5, cofactor was positive 5. Minor was for M22 was minus 4, and the cofactor was also minus 4. M32 was negative 3, but the cofactor was positive 3, just fine. M13 minor was 4, cofactor was 4. M23 minus 8 and 8, and M33 minus 6 and minus 6. They got it right. You can rest easy now. Okay. Now, here's another definition. Everybody got this? Do you need it any longer? Okay. All right. The definition below is called inductive because it uses the determinant of a square matrix of order n minus 1 to define the determinant of a square matrix of order n. Okay? So here's how this definition goes. If A is a square matrix, that's the given, of order greater than or equal to 2, Okay? Then the determinant of A is the sum of the entries of the first row of A multiplied by their respective cofactors. Okay? That is determinant of A. They like to write DET. I just like to do that. They do them both, actually. Is equal to, and this is really clarifying it, right? J equal 1. This really makes a lot more sense, doesn't it? Up to N, because you got N rows, N columns. 1J times C1J. Okay? Which would then be A11, C11 plus A12, C12 plus A13, C13 plus plus A1N, C1N. Okay? Yeah. Goodness gracious, my eyes are just stinging. Okay. Now, what's that saying? Square matrix, order n greater than or equal to 2. Okay? If that's what you're given, then the determinant of that matrix is the sum of the entries of the first row of A multiplied by the cofactors. Okay. Now, understand if n was a huge number, 7, 5, anything such as that, then the cofactors are going to be, to determine those, you have to keep doing matrix after matrix after matrix because you get down to 2 by 2s always. So you may have, there may be a lot more work in there than what it sounds like. But it's the sum of the entries of the first row of A multiplied by their cofactors. So that would be, the determinant of A would be the sum, and you just take the first row, where I is equal to 1, and multiply each first row entry by the cofactor of the matrix, which we defined earlier. I don't know if it's the glare or what, but it's dropping my head crazy. So you're just using the first row. So it's A1 and C1. In every one of these, A1 and C1, and you're counting over then the rows. 1, 2, 3, 4. So you're just doing that first entry times the cofactor here, plus this factor times the cofactor there, plus this one times the cofactor there. You just do it. And that's the determinant of the matrix. Because if you think about it, every time you do a cofactor, you've done all the matrices below that. So you've really combined everything. So you only need to do one row. Very soon, we'll say it doesn't have to be the first row. It can be any row. And then after that, we'll say it can be any row or any column. Just go down a row or column, any row or column, and just do that. Itself. The numbers in front will change, okay? But all the rest of it stays the same. Or if you're doing columns, then the second number will stay the same, and the first number will be the one changing. Okay, so that's your definition of the determinant of a square matrix. Okay? When you're using that definition to evaluate a determinant, you're expanding the cofactors in the first row. That's what it's called. So we're going to do that without too much emphasis on form. We're just going to do it. Okay? Here's matrix A. Is this the same one we had before? I think it was. Yeah, it's the same one from example 2. Okay? 0, 2, 1. 3 minus 1, 2. 4, 0, 1. Okay. Oh, man. We want to do the determinant of A. And we've already done the cofactors. So, but you know, I'm going to show you how to do it without having to worry too much about that. Okay? It's kind of combining everything we just did. I find it's doing it in a little bit more reasonable order. Okay, first, for that first entry, okay, so now the determinant of A is the determinant of that thing, which is this. The first entry, 0. It doesn't matter what the determinant of that is, you're multiplying by 0, right? So that first one's 0. Thank you very much, that one's nothing, okay? So we don't have to even do that one, okay? That gives us a 0. All right. We're doing the first row now, so let's do it. Here's a 2. That's the entry, right? Let's do the sign with that, because we do plus minus. So let's make that a minus 2. And then all we have to do is the determinant of here. So you don't have to go back and figure the cofactor by sign. You take the sign out to begin with. That's why I say the minors and cofactors, that's just a little extra work. If you just incorporate the sign of the cofactor in with the number you got it from, it's done. And you don't have to go back and do it twice. You don't have to do the minor first and then the cofactor. Just do the sign of the cofactor with the number and go from there. And then you just do your determinant. That would be 3 minus 8 is negative 5. So that's times a negative 5. Done. Okay. Now, let's erase that. We're going to leave that one because we're going down the first row. Okay. All right. So now let's go to, we did that one. Let's do this one. What's the sign for the 3, 1 entry? Positive. So we're just going to do 1 times yeah, oh, okay, I got you. Let me do plus 1. Let me do that. Plus 1. Okay, here's what I was going to say. Well, when you got ahead of me there, it sort of threw me off. We're doing this one. So what sign do we put here? Plus minus plus. Plus 1. Okay? That's that part. And then do this, and there's where you got your 0. Four. Okay. That's it. So what is this? 10 plus 4 equal 14. You just got the determinant of that one. Okay? Pretty easy. Okay? Now, you can do any row, any column. It works the same. Now, let me give you a hint. Now, the book's going to give it to you later. I'm going to give it to you now. It was not a bad idea to do the first row because that had a 0 in it, because that 0 enabled us to not have anything for that first entry. So if you're going to do any other row or any column, which one might you choose? Okay, you could do row 3. You could do column 1 or column 2. All 4 of those have a 0. If any of them had 2 zeros, go for that one, okay? Go for the row or column with the most zeros, okay? And it doesn't matter which one, okay? So you could have done the first column. Let's just do that quickly and see if we can, just by arm waving. Ooh, okay. First column, going this way. So that's going to be, what is the sign of this position? Minus. So it's minus 3 times 2 minus 0. Minus 3 times 2 is minus 6. Jot it down. Okay. Then we're going to do 4. What's the sign of that position? Plus. So it's plus 4 times 4 minus a minus 1. So 4, this is an addition. That's a 4 plus 1, 5. Right? 4 plus 1 is 5. 4 times 5 is 20. Right? 20 minus 6 is 14. Right? There it is. Okay, let's do the third row. I'm doing these with the zeros because they're easier. What's the sign of that position? Say that again? Plus, okay. Okay, so that's plus 4 times, we just did this one. 4 plus 1 is 5. That's a 20, right? What's the sign of this position? Plus, okay. Hint, diagonals are always plus. Every diagonal is plus. So that would be a plus 1, so we have a 20 plus 1 times
6. So
minus 6.
-6.
Yeah. So 20 minus 6, 14. Okay. Let's do the second column. Okay. What's the sign of that position? Huh? Minus. Okay, so it's minus 2 times 3 minus 8 minus 5. So it's a 3 minus 8 is minus 5. And minus 2 times minus 5 is plus 10. Okay, what's the sign of this position? Plus, but it's a minus 1, so it's a minus 1 times 0. Yeah, minus, okay, 4. Minus 4. Minus 1 times minus 4 is 4, plus 4. And 10 plus 4 is 14. Yeah. So, works whichever. Now, you could do it with this one or that one that have 3 entries in it. Fine, knock yourself out, but more zeros to have, the fewer calculations you have. Any row, any column, pick one with the most zeros. Okay. Now, they did a few also. They did some with 3 of them in it. Okay. Why, I'm not sure, but it works. Let's move on to Theorem 3.1. All right to erase? Yeah. Okay. Expansion by cofactors. I don't think I have to write this. We already said it. Let me just say. Let A be a square matrix. Well, I don't do it. Okay. A square. Okay. Order n. Okay. Excuse me. Then the determinant of A is given by the summation. Well, this time it's a little more general. The summation where J is equal to 1 to n. That all looks the same. But this time you do a I J C I J, but I don't, you can do them, which would be a I1, that's I1, C I1 plus A I2 C I2 plus A I3 C I3 plus dot 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 plus, and get out to the n, and that would be A I N C I N. Okay. That's if you're doing the ith row. Notice the i's are always in there. Ith row expansion. Or do the I equal 1 to n of Aij, Cij, and that would be A1j, C1j plus A2j, C2j plus A3j. My screen is leaving me now here. C3j plus plus A3, no, ANJ, CNJ. Okay, in other words, you're doing down a column. Whichever one, the jth column, ith column. No, jth column, whichever, j somewhere between 1 and n, 2. Okay? So it doesn't matter which way you go. Now, do I quite do it exactly that way? I do the same principle, but I find it a lot easier to incorporate the sign of the C and then with the coefficient, with the first number, and then just do the minor. Now, you think in terms of minor. Now, when expanding by cofactors, you do not need to find cofactors of zero entry. We just saw that. So the rows or column containing the most zeros is usually the best choice for expansion by cofactors. Yes. Okay, how are we doing on time? What's that?
4 minutes over. 4 minutes over.
Over? Oh, guess what? No extra charge. Okay. All right. So we'll pick up next time with example 4. Sorry we didn't get to example 4 today. That would have been a lovely example. But of course, y'all will remember all this because you're going to practice on this like crazy over the break, right? As you're working on your test, which I'm about to give you, homework exercises here, you can do any of the odds 1 through 11, any of the odds either 13 or 15, you can do 17, and you can start doing any of the odds 19 to 31. That's a lot of them, and you can do 33 if you want to too. I don't know why they did it separately. Ooh, you can even try to do 35 and or 37 if you'd like. Okay, we'll hold off the rest of those till later. All right, for any of you who did not get the test last time, test 2, and for who were not here to hear me pitch it this time, I need research papers. That's the spring break week coming up. Great time to work on research papers, yes. And to finish test 1 and to finish test or work on test 2 anyway. You may even be able to finish it. So any of you need test 2? And you're not going to get one for just you.
I can see if he can come up here today or...
Yeah, before 6 is late, but he needs to let me know if he needs it on. Actually, I'll carry it to the Birmingham campus. If he comes by Birmingham campus tomorrow, I'll have it there. It needs to haul it around all spring break week because I'm not coming back here after today. So, but that's okay. I don't mind. All right, good deal.
Did you you didn't do it for Cal 3? Are we on the second test? Did you pass that one out too?
Okay. Cal 3. I think I did give him a test. I'll have to go down and check, but let me end this because
I know we were getting kind of
he at me if I didn't give you some math to do during spring break, you know?
Yeah.
I did not want you angry. Okay, where did that go? It didn't go in.